So, hello everyone. My name is Erlon. I work for NetApp. I'm a software developer. I have been working with Cinder since the Liberty release. And this is Thiago. He's also from NetApp. He's a software developer. He works with Cinder and also with Manila. And also, we should have Gorka Giler here with us. He's from Red Hat. We have been working with him in this last release, solving some problems that Red Hat and some other problems, or some other clients were having with the Cinder Thin Provisioning. So we realized that most of the problems could be happening with more people than the ones that we are having to deal in this release. So we had this presentation in mind to give people a better understanding on how the thin provisioning on Cinder works, and also how the scheduler on Cinder works, because that might be a bit obscure for some people. We propose this session where we're going to show you some topics on the scheduling, how the scheduling decisions are made, and how the features and how the layers are used, and also how the thin provisioning was designed on Cinder and how it worked, and how it's supposed to work, and why it's people were having so many problems with thin provisioning. So also we're going to have some troubleshooting lessons that we use to use. And we're going to mention some things that we are doing in order to avoid those kind of problems in the future. So, Thiago, you might want to start.
OK. So before we start talking about thin provisioning, I'm going to give a brief overview on how Cinder architecture is organized and how the scheduler works. So for anyone unfamiliar, Cinder and many other projects, many other OpenStack projects, work with microservices. So Cinder basically has 3 different microservices. The API, which is the entry point for all the requests. It has the scheduler, which chooses pools based on the request that it gets. And we have the Cinder volume, which is responsible for actually making those operations on the storage devices through the driver. And all these three different microservices, they all talk by RPC requests. So the API is the entry point for all the requests. So all requests that you made for Cinder, they all go through the API first. Some of them are already handled on the API. So if you're making some requests that only need to check the database, they all are being handled on the API itself. So for example, list volumes, show a volume, all these attributes are already on the database, so it does not need to go through the scheduler or to the volume service. Some other type of requests go directly from the API. Oops, sorry. Go directly from the API to the volume service. So for example, if your request already knows which pool will handle it, for example, delete a volume, delete a snapshot, it already knows which pool has this volume to be deleted or the snapshot to be deleted. This request will go straight from the API to the volume service. And most of the other requests go through the scheduler, so that the scheduler needs to check which pool most suits this request. So the scheduler will look through the list of pools and choose which one is the best to suit this request, to receive this request. So this is how does the scheduler does this decision. So how does the scheduler chooses? What does it know? I don't know what's going on.
There you go.
OK. So the scheduler has some information. So the information about the capabilities of each of its pools. So it has information about its total capacity in gigabytes, how much of it is free, which other capabilities it supports. So for example, does it support thin provisioning? Does it support QoS? Which is the availability zone, which is it's located. And all this information is replicated across all scheduler services which is running. So you can have one or many Cinder scheduler services running on different nodes. You can also have one or more Cinder volume services running. But the difference is that the Cinder scheduler already runs, they all run at the same time, so it's distributed. But the Cinder volume, they only run in active passive. So in this example, we have the bottom service is active, and the other one is passive. And this information go from the storage device to the volume and all the way through the scheduler by the RPC requests, RPC calls. So those information are updated on several occasions. So the first one is at the service startup. So when the service is startup, it will pull the pools for the information and then send it to the scheduler. Also, when it has the Cinder volume service has some periodic updates. So from time to time, it asks the pools for the information that it needs, and then it updates the scheduler. And the third way to update this information is via the request. So whenever a scheduler gets an API request, it will update its pool with the information. So for example, if a certain pool will get a new volume, it will update with this volume capacity and so on and so forth. But the one thing to remember is that those different services, they are not being synchronized. So each service will have a different information at one time, and they will only get updated once this go to the Cinder volume, and then it queries the storage, and then it will update all of the Cinder scheduler services. So here we have an example on how this request will be made. So how the scheduler will choose a pool to receive a request. So in this example, we have 4 pools. Each pool has some capabilities. So some support multi-attach, some does not. Some support QoS, some does not. Some they all have different free capacities. They all have different total capacities. And here our request is asking for a 100 gigabyte volume with QoS, multi-attach, and availability zone 1. So looking at all of our pools, we have 2 pools on AZ0, 2 pools on AZ1. We have some pools that support multi-attach and one that it does not. So as we can see, the scheduler will filter out the request that does not fit, the pools that does not fit this request. So the pools that are grayed out don't have all the capabilities that the request is asking. So they are grayed out, so they are filtered out. So we are left with those 2 pools, and they all match the request that we got. After that, I mean, those are the filters that we have. So we have a bunch of different filters that will filter based on different capabilities. So we have, for example, the capacity filter, which will filter out pools that does not have the capacity that the request is asking. We have, for example, AZ filter, which will filter out pools that are not on the availability zone that the request is asking. And we have many other filters that you can choose. And by default, Cinder is configured to use the availability zone filter, the capacity filter, and the capabilities filter. So those three are the default filters that Cinder will use. And after filtering out the pools that do not fit the request that we got, Cinder will also, the scheduler will also try to find the best one, which of the rest of the pools, which of the pools that we still have, which of them best fits this request. So here we have the weighers. Here's where the weighers come in. So they will give scores to each of the pools based on those capabilities as well. So in this example, the only weighter that's being used is the capacity weighter. So it will give a score to each pool based on its capacity. So based on its free capacity. So here we have a pool that has 8,000 gigs of free capacity and one with 1,500. So obviously, the one with 8,000 gigs of free capacity is better. So the score in this one is bigger than the score on this one. So this is going to be chosen for receiving this request. So those are the weighers that we have. By default, Cinder only uses the capacity weighter, but we have so many others to choose. We have, for example, the goodness weighter, in which we can write a function to give a score based on capabilities or based on other features that we have on our storage, or it can use a default function from the driver. So now I'm going to give back to Arlan so that he can talk about the thin provisioning and the problems that we were trying to fix.
So we know that there are some storage that support you creating a volume. Actually, most of the storage supports you creating a volume or a LUN and not allocating all the volumes that you're consuming, right? But initially, Cinder didn't have support for storage that did this feature. So storage that wanted to have the thin provisioning, they needed to report infinite or unknown to the scheduler. And then when the scheduler would go to do the decisions of space, it would check the field, and if the storage was an infinite capacity, it would only allow the creation of the volume. The problem with that is you have no control on how much you are over-provisioning. So you could say, we could have something like a pool with 100 gigabytes, and you would be able to create 10 petabytes of volumes inside that pool, and you would not have a way to limit how much you would want to over-provision on that. So initially, in Kilo, we started to work with the over-provisioning support for Cinder. We did the first implementation, some driver support that in Kilo. And then in Libert, most of the storages that support and that currently has support for thin provisioning added support for thin provisioning in Libert. So the idea was initially support a set of use cases and possibilities. One of those possibilities is, for example, imagine that you have some classes of services, some tiers in your cloud, and you want to have the over-provisioning as part of your quality of service. So you could have a a platinum service that would have no over-provisioning. All your volumes would be thick. So we would guarantee that the users would never run out of space. We could have a gold service that would be, like, let's say, an over-provisioning of 10, meaning that the user could create up to 10 times more volumes than the real space in that service, and so on. So also, the implementation had in mind that the pools reporting could be thick or thin, and also that there were some services, some backends that supported the creation of volumes both thin and thick. So before we proceed with our demonstration, with our talk, let's settle some concepts. Those concepts, some of them are very, very simple, very, very basic, but given the nature of different vendors or different developers, some concepts got misleaded, and some people understand they in a different way. So the first one is the total capacity, which is exactly the capacity that you have. Let's say you allocate a pool with 1 terabyte, and then you start creating thick volumes of 100 gigabytes. Then you will be able to create 10 volumes, right? Because all your volumes will really allocate the space right away, even before people start writing data on that. The free capacity is the blocks that are not being used at the moment. So in this case, in the previous case that I showed, if you have the 1 terabyte pool and you allocate 100, you allocate 10 100 thin volumes, if they are thin, that means that the storage will not allocate the blocks right away. So after you create that 10 volumes, your free capacity will steal the 1 terabyte, right? Because you haven't done any write, any I/O on that on those volumes. The allocated capacity. This is a very controversial as well. When you create the 10 volumes, let's keep with the same example, your allocated capacity, if you create the thin volumes, is 1 terabyte, because you will have that allocated. For the thick volumes, that's exactly the same. The provisioned capacity is the same concept, but it's calculated by the driver, meaning that the Cinder scheduler receives some stats, and if the driver is not able to calculate the provisioned capacity, Cinder will go and count all the volumes in the database and say to the schedulers, hey, this is the number of volumes that I have in this pool, and this is what I think is allocated for this pool, right? These two values, they can differ a bit because some backends have a different way of summing and calculating, making the calculation of the space. Some backends can be used by another project, or something else can go and create volumes not managed by Cinder in that pool. So the allocated capacity and the provisioned capacity can change, can vary one from the other. The oversubscription ratio is the ratio between the provisioned capacity and the total capacity. So in that example, that I have one pool of 1 terabyte, and I have allocated 10 volumes of 100 gigabytes, my oversubscription ratio is 1, because I have 1 terabyte of volumes in a 1 terabyte pool. If I had the opposite, if I had more volumes on that same pool, more thin volumes, for example, if I had 2 terabytes of thin volumes, let's say 20 100 gigabytes of volumes on that pool, then my oversubscription ratio would be 2, right? And the reserved percentage, which that is a space that Cinder will just reserve and not allow volumes be created over that reserved percentage. So the way this would work on the driver side is, as I mentioned, the driver would need to report the provisioned capacity. If the driver didn't have a way to report that or simply didn't report, then the Cinder would do the calculations for the for the allocated capacity. Also, the driver would need to report what would be the max oversubscription ratio for each pool, right? And the other thing the driver would need to report would be if the driver supported thin provisioning, thick provisioning, or both. So to use that as an admin, the admin need firstly to go and create an extra spec. We have 2 formats that is possible to be used. We can use the capabilities and then column thin provisioning support, which can be true or false. I can have these in the same type, for example, or I can report it in this different format. Both of the formats are just optional. They should, the 2 ways work in the same way. And also, I have to configure this max oversubscription ratio for each pool that I'm configuring. So after the implementation was done, people started to have some problems. So you go, the admin went and did all the configuration, did all the calculations, create the pools, etc. And when he tried to do the tests and create a volume in a situation where it should be possible to create the volume, he just couldn't create the volume. And in other situations, it should not be possible to create a volume. Let's say he had configured 4 pools with 1 terabyte each. He had configured the max oversubscription ratio, let's say to 1. And after filling all that capacity that he was provisioning, he was planning, the scheduler is still allowing creating more volumes and more volumes beyond that the limit. So what was happening in the situation? The problem with the implementation was several problems. Initially, the terminology, as I mentioned, confused some people, mainly the developers. People started to implement drivers, and the drivers weren't reporting the values that the driver should report. Some drivers reported the values, but the meaning of the values for the backend was another meaning. So there was no way that all drivers would work in the same way if each driver would report a different value. Value with different meaning in the back. Some drivers still had its own way to implement overprovisioning. Because Cinder didn't support this before Kilo, some vendors implemented this in the driver side. So there was 2 ways to implement the overprovisioning. There was some driver-specific way of implementing. There was the Cinder way of implementing. So in the beginning, the releases after Kilo, people start to struggling to work with that. There was also some development bugs, just things that can happen. Also, another problem is that operators we're having a bad time trying to configure the max oversubscription ratio. Imagine the following situation. You have your pool. You create your 1 terabyte pool. And then you set your max oversubscription ratio to 10, meaning that you can create 10 terabytes of volumes, right? And then, because you believe that your users will not use all the data right away. And then your users start creating volumes, but not using the space. And then you reach the 10 terabytes limit. And now you say, all right, and go, why my Cinder, my college cannot create more volumes? And then you go and check the logs and see that, well, I still have volumes, so I know I need to change this max oversubscription ratio. And then you go and change from 10, you change to 20. And then after some time, the same thing happen again. You still have space in your backend, but you still overprovisioning, and your users are just creating volumes and not using them. So the admin would always need to go and restart the volume service, and sometimes they ask us, well, what should I use in this parameter, this configuration? And then we didn't have a good option to suggest for them. Another problem was the lack of synchronization between the scheduler. As we mentioned, the three schedulers, the scheduler services can be run in active. But the volume counting for each of those services are not synchronized, and there are several race conditions that happen when you start creating volumes and the volume service send updates up and back and forth. So those are some problems that we needed we started to working on them after the first implementation. And in this last release, we address lots of them. The terminology problems that was confusing the drivers, the drivers maintainers. We added some more documentations. We discussed all that concepts. We tried to educate people to understand and have a common understanding of the volume of the terminologies among the drivers. There's a big list of bugs fixed since from Liberty until Queens. We deprecated some driver-specific way of doing thin provisioning. We added support for a new way of using the max oversubscription ratio, which now you can use auto, so you don't have to go and change every time that you reach that limit. And also, we're still working on the race conditions that happen on the scheduler. So, as a usage guide for the thin provisioning, I would say that if you have, first thing that you have to do is check if your storage supports thin provisioning. And that can change a bit because some storage supports thin provisioning, but they doesn't support you create a thin provisioned loom, or don't support to create the way that Cinders understand as thin provisioning. So firstly, you check if your storage supports thin provisioning. Then you check if your vendor, the storage vendors, provides Cinder support for thin provisioning. I have this list here. Those are the ones that currently support thin provisioning. Then you have to configure your storage to use the thin provisioning. And then you have to configure the Cinder specific parameters to support thin provisioning. I'll show in a minute. And also, you have to configure the extra specs, and then you have to test your setup. So those are the config options for thin provisioning. First, the max oversubscription ratio. We always use a value bigger than 1, equal or bigger than 1. You can use auto. What's happened here with the auto parameter, it will, how can I say that? It will basically allows you to create volume as long as you have space, right? As long as you have free space in your pool, you will be able to create volumes. After you run out of space, you won't be able to create volumes anymore. For most use cases, I would recommend the use of auto. The reserved percentage, which is a value that can slide from 0 to 100, is the value that I would recommend. Actually, I can't recommend a value here because it depends on how fast can you add more disks to your storage. If your company takes like 2 weeks to go and buy more disk, maybe you should consider, and depending on the size of your storage or the size of amount of disk you need to add, you should, let's say, 15, 20%, I don't know. Maybe this is something empirical that you guys can say better than me, or what is the best value. And also, there are some backend specific config options. For example, for NFS volumes, you have this parameter, NFS sparsed volumes, and this basically says to use thin provisioning, right? So it's not completely straightforward. And there are also other parameters, other configurations that you have to set that are specific for each of those backends. So you have to go and check with your vendor if they support and how they support that. So you also have other additional configuration options. Those are not mandatory. You can use that depending on your use case. You can use, for example, this is the default for the scheduler default waiters, which is the capacity waiters. It will do the scheduling we do the classifying of the pools based on the free space of the volume. If you use the allocated capacity, it will use the allocated capacity as a measure. Also, you have a multiplier, which is used in most of the case to stack or spread the volumes. For example, the default for this parameter is 1. Usually, you don't have to concern about this because most of people want to have the volumes spread across all backends and all the loads that you have. But if you want, for some reason, fill one pool and then fill the other one and then fill all the other pools until you reach out of space, then you can change this to -1. And you go to this value. Also, you have the same for the allocated capacity. And so, let's suppose you are having some problems. OK, Erlon, I just should not be being able to create these volumes. I am able to create 100 times more volumes than I should. What should I do? First thing that you have to do is to know what release you are. Because if you are using some OpenStack distro, for example, Red Hat, most of the fixes that we did since from Queens are backported back to Mitaka. So you shouldn't have those problems, or if you are updated, most of the problems that we have here with thin provisioning should not be happening with you. So maybe you have just skipped some upgrades. So you need to check with your cloud provider. I mean, your Red Hat or Ubuntu, you know. Well, if you're not using any of those services, then you will need to spend some time digging. First initial thing to do is to have a cleaner way to reproduce the problem. I always recommend people, if when possible, create another set of pool. If you have a POC environment, go into the PRC environment, clean our volumes, clean our logs, and try to reproduce the problem. You have the release notes saying what of the problems have been solved. So, for example, if you're using Mitaka, you might want to look at Liberty release notes to see if there's something related to overprovisioning there. And then you have to check the logs, pay attention on the timing of the logs, because the time is very important to understand the synchronization problems. And understand if the problem is a synchronization problem or if is another of the bugs that we have already solved in the last releases. Also, it's very good to look at this file. Is the capacity filter. Is not a big file. It's a part of Cinder code. It might want to help you to understand why your volumes are not being scheduled, right? Another thing that I did, you can rely on this in this list. I picked from since the Liberty release, all the bugs related to overprovisioning. Now, so if you are in these older releases, you might want to look at in this list, see if you are using one of those drivers. And this could be the problem, the source of, sorry. This could be the source of your problem in one of these bugs, which you could just go and backport and apply in your, if you're, if you are self-supported and you're not relying on Red Hat or Ubuntu for do that for you, right? So here I have the ones from Mitaka, the one from Newton, Okata, Pike, and the ones from Queens that we did a big work on that one. This one, which one's fix start old report? This last one is a very important one. This is a very simple fix that can be backported back to Libert or the release that you are using. This fixes a lot of the problems, the concurrency, not all of them, but a lot of the concurrency problems. So this is something important to know. And that was it. Here you have some reference that I use in the presentation. If you want to get this presentation, I will send to the organization so they can upload in this link. You can also just get with me in the end of the release or outside. And that's it. I hope we have give you some. I hope you have shed some light on the problems, and we might have helped you guys in some ways. Now we can have some questions.
Could you please go to the microphone?
Yeah, we need to go to the mic, so you
hello.
get recorded.
Thank you for the presentation. I was just wondering if Ceph is supported for the thin provisioning.
Yes, it is.
It is?
Yeah.
Because I couldn't see the on the slides.
Yes, it is.
It is?
It
okay.
is.
Thank you.
Yeah, I might have skipped it. Yeah, the thing is, each driver has a different way of reporting and making this Cinder know that it supports Cinder provisioning. So sometimes you grab for a value in the logs and in the code, and the driver does not report in the same way, and you lose it.
And following the same Ceph conversation, we're using not only Ceph Cinder, Ceph through Cinder, but also Ceph directly through Nova, so that Nova provisions like local volumes on Ceph storage.
Nova provision?
Nova.
Nova provision, how is the configuration for Nova?
Yeah, the ephemeral storage is being used on Ceph rather than on
Okay, got it.
And this also screws up the disk space calculation for the nodes, because every node reports that it has available disk space of the whole Ceph cluster.
Are you concerned?
Huh?
Do you work on CERN?
Nope.
Because I know they are doing something like that. Yeah, and so?
Yeah, we're a small shop with private cloud, but yeah. So the concern is that the disk space reporting is screwed up with Nova working with Ceph directly for ephemeral storage. And I wonder if you are already also considering to fix that issue with your work as well.
Yeah, we don't recommend this configuration exactly because the scheduler will mess up with all the things. With Ceph, Ceph is sending, when Ceph do the reporting of its free space, it needs to go through all the volumes and do the accounting and send to Cinder. And as it will be counting volumes that's not being managed by Cinder, the scheduler will rely on a number that's not exactly the number of volumes that is being used. So you might have some problems with this configuration. I know that people do this for, some folks do this because they want to try to have a more reliable way. They want to have several backends pointing to the same Ceph cluster. So it is supported, it works, but you might have some problems.
Just to add on it, I think it's quite a common configuration for Ceph users, since there are advantages from having one Ceph backend for both Glance and Cinder. And it is quite often used.
Very often used. Yeah, good to know, good to know. Welcome. Yeah, I think. Yeah, we can talk later. I think we're running out of time. Do we have time for other questions, or it's okay? Yeah, I have to finish. Okay, thank you, everyone.